First of all, let's take a look at the example 5.13. So here is background information. I don't want to read it over or here, but what we need to know is we have the joint PDF of x and y. P of x, y is always equal to 1 over 20. And the possible values for x is 1 through 5, which means x could be equal to 1, 2, 3, 4, and 5. And y could be 1, 2, 3, 4, and 5 as well. But there is exception, which is x is not equal to y. X cannot be equal to y. And we have the expression of h of x, y here is equal to the absolute value of x minus y minus 1. And we want to find the expected value of h, x, and y. That's what we are looking for. So based on the proposition we just went over, this thing would be equal to summation over x, summation over y, h of x, y times p of x, y, right? That's what we have from the proposition. That's what we have from the proposition here, because we're dealing with two discrete random variables. That's why we need the, of course, I'm sorry, there should be summation over y. Summation over y. Okay, so basically, if we wanna find this double summation here, we need the PMF of the joint PMF, which is given here is a constant number 1 over 20, like always. Okay, and then we need the function value of h of x, y. Okay, if we are able to find all the values of h of x, y, we just need to use each function value multiplied by 1 over 20 and then add them all up. We'll find the expected value of h of x, y here. Okay, now let's take a look at what we need to do down here. So what is given here is that we list all the possible values for x and all the possible values for y. So what's given here in the middle are those numbers are the possible values of the h of x, y. Okay, and based on the PDF, the joint PDF given above here, we can tell x could be 1 through 5 and y could be 1 through 5 as well. But there's exception, which is x is not equal to y. So basically, that's why we get nothing for the pairs in which x is not equal, x equals y. That's why we get nothing, because x cannot be equal to y, right? And then since if we want to figure out the double summation here, we need to find each function value. We need to find all of the function values of h of x, y. So what do we need to do? Just plug each outer pair back into the function expression. Okay, now for example, just like what we did over here. So double summation x from 1 to 5, y is from 1 to 5, and this is the h of x, y, of course, and this part is p of x, y. So actually, what we're doing here, we are adding each product of. We are adding the product of each function value on the joint PMF. So what we need to do here is, if we want to find the function value, we need to plug each possible outer pair given in the table here back into this expression to find the corresponding function value. So for example, let's see this outer pair here. So in this case, x is equal to 1, and then y is equal to 2. And then we plug those two numbers, those x and y values back into this expression. So x minus y, absolute value, minus 1. Let me write this real quick. Is equal to, in this case, it's going to be 1 minus 2, absolute value minus 1. So this would be 0, because we have negative 1 from here. The absolute value of negative 1 is positive 1. 1 minus 1 is 0. And that's why we have the 0 over here. And then let's take a look at second outer pair here. So in this case, x is 2, y is 3. So same thing, we plug those two values, this outer pair back into this expression here to find the corresponding function value. So that would be x is 2. X is 2, minus y is 3, and then minus 1. So we have absolute value of -1 minus 1, which is 0, and that's why we have 0 over here. Okay, now let's take a look at this. When y is equal to 3, and then x is equal to 1. X is equal to 1. So in this case, we're going to have x is equal to 1 minus y is 3, absolute value of that, and then minus 1. We have absolute value of -2 minus 1, which is 1. That's how we got the 1 here, and so forth. So once we get all of the corresponding function value in the table, and then we just need to use each function value multiplied by the joint PMF here, and then add them all up. So which means it's going to be equal, this summation is going to be equal to this function value here, 0 times 1 over 20, and then plus 1 times 1 over 20, and then plus there's another 0 times 1 over 20, and then plus there's another one, 2 times 1 over 20, and then plus this 1 times 1 over 20, and then times that 0 plus 0 times 1 over 20, and then plus this is a 3 times 1 over 20, and then plus this is 2, which is the function value, 2 times 1 over 20, and then plus this is 1 times 1 over 20, and then plus 0 times 1 over 20. And then you would do the same thing again, since because this table is kind of symmetry. This is symmetry, right? Because we get a 1, 3, and get a 3 here, and then 2 2s, and get 2 2s, and we'll get 3 1s here. So actually, instead of adding the rest part, we just need to actually multiply by 2 at the end. I would just put it over here. Multiply by 2. So if you type this out in your calculator, you'll have this is equal to 1, which is exactly the same thing as what we got here. Okay, that's how we find the expected value of the jointly distributed discrete random variables. Okay, I think so what you need to do, just apply this proposition here, and this proposition is very similar to the formula we saw before. So the only difference, since we're dealing with 2 random variables, we need to do the double summation here instead of only once over here. Alright, that's for the discrete random variables. Let's take a look at another example for if those 2 random variables are continuous. So this is example 5.14. Example 5.5. So that's coming from the previous example we saw in one of the lecture videos of section 5.1. So in the example 5.5, the joint PDF. So since the PDF, we're dealing with the continuous random variables. The joint PDF of the amount x of almonds and amount y of cashews in a 1 pound can of nuts was this. So we have f of xy is equal to 24xy. So where x is greater than or equal to 0, y is greater than or equal to 0, and x plus y get b less than or equal to 1. And the problem says here, if 1 pound of almonds costs the company $1 and 1 pound of cashews costs $1.5, and 1 pound of peanuts costs $0.5, then the total cost of constants of a can is this. H of xy is equal to the amount of almonds times the unit price of 1 times x, and plus the amount of cashews times the unit price, which is 1.5, and then the amount of peanuts, which is 1 minus x and minus y, because the sum of all the amount of almonds, cashews, and peanuts are supposed to be equal to 1. So that's why the amount of peanuts is 1 minus x minus y. Okay? And the unit price of peanuts is 0.5. and then we add this all up. We have h of xy is equal to 0.5 plus 0.5x, and then plus y. And then if we want to find the expected value of h of xy here, we just need to apply the proposition given here, the double integration from negative infinity to positive infinity, h of xy times the joint PDF, f of xy, and then dx dy. And then, of course, what we need to do is just put the specific intervals for x and y here, and then we plug the expression of h of xy and f of xy back into here. So h of xy is equal to 0.5 plus 0.5x plus y, and f of xy is equal to 24xy here. So I would like to emphasize how to find the boundary here, 1 minus x. Okay, so we just so when you are dealing with a problem like this, the very first thing you want to draw the region of the possible order pairs, or the positive density region. Okay, so let's take a look at this again. So we have both, this is x, this is y, right? So this is 0, and this is 1, and this 1 here. Okay, so since both x and y got to be between 0 and 1, so we have a square over here, right? Which could be the possible positive density region. But we have another condition here, which is x plus y less than or equal to 1. And if we want to draw the boundary or draw the region bounded by this inequality, we need to draw the straight line x plus y is equal to 1 first. I think you have learned this kind of stuff from your previous class, like pre-calculus or college algebra, something like that. And then this would be equal to, this is equivalent to y is equal to negative x plus 1, right? So we need to graph that straight line first. So in this case, if x is 0, y is going to be equal to 1. When x is 1, y is 0. So we have 0, 1 here, and then 0, 1 here. And then we draw a straight line. Since we have less than or equal to sign here, we need to shade it down, right? So this part would be our region. This shaded part would be the region. So I will clean this part. Oops. Let me just clean it out and redraw it. So we get the coordinates here, 0, x, and y, and we get a 1 here, and a 1 here, and a straight line. As what I just mentioned, this triangle shaded here is the positive density region we're looking for, right? Which means that the double integration of the adjoint PDF above this triangle would be equal to 1. Okay, which means the sum of all probabilities is equal to 1. But the key point is to find the boundary of x and y. So if we have two random variables and the positive region is not a rectangle, so we want to fix one variable and find the boundary of the other variable. So what I usually do is I usually fix x. So x less x fixed between 0 and 1. So if x is over here, then we can tell the interval of y would be between this point and this point here, right? This is the y coordinates, right? And we know that this straight line is y is equal to negative x plus 1, right? So if we fix this x value, then the y value in terms of x is going to be negative x plus 1, or 1 minus x. So this y coordinate of here is going to be 1 minus x, right? And then this is 0, which means y got to be between 0 to 1 minus x. That's why. I would say this again. This is a super important, because once you find, first of all, you got to draw the positive density region, which is something like the triangle we have here. That's number one. And next thing, which is even more important, is that you got to know how to find the boundaries of both x and y. So if the positive density region it's not a square or it's not a rectangle, and you want to fix one variable and to find the boundaries of the other variable, like what we just did. So once we got that, so regularly if we want to find the expected value of h of x, y here, we just need to plug the specific intervals for both x and y. So of course, as we fix x value here, so we get it from 0 to 1, and then the interval of y is going to be from 0 to 1 minus x. And then we bring the expression, the specific expression of h of x and f of x, y, h of x, y, and f of x and y back into here. So for the calculation part, I wouldn't spend too much time on the calculation part here, because if you distribute those 24xy to the parentheses, it's just like some basic, you just need to apply the power rule for each term and to finish the calculation. I wouldn't spend too much time in the lecture videos, but I will upload the calculation part of this problem, example 5.4, to Canvas. So you will see another PDF file under the lecture notes called example 5.14. So that would be the calculation for this thing here. All right, and that's pretty much all I want to talk about the expected values. So actually, this is the idea is pretty much the same thing as what we saw before. If you want to find the expected value of a random variable or expected value of a function, you just need to do the integration of whatever the function of random variable multiplied by the PDF here. Okay, you just integrate the product here. You will find the expected value. All right, that's pretty much all about this video.